Topic number 4-1, blocks and boxes. For number 1, we're going to want to take an algebra tile approach to this problem since we have an algebra tile area to work with. Go ahead and draw your table. This piece can be represented with an x squared. This piece can be represented with an x along with the other pieces here, so this one's an x piece, this one's an x piece, this one's the next piece, this one's the next piece, so on and so forth. And the same for these three pieces right here. These pieces can be represented with ones. They are our unit squares, these are our x rectangles, and these are our x squared units. In order to find the product, we take all of our pieces. We've only got one x squared piece. We've got 5 x pieces here, 3 x pieces here, for a total of 8 x pieces, and 15 1 pieces here. So for our product, we have an x squared, we've got 8 x pieces, and we've got 15 1 pieces. This is our product so far. In order to find the factors of this product, we need to think of this as an area. Think of it as a rectangle. In order to get the area of a rectangle, we end up multiplying its length times its width. In this case, this length right here would be an x. An x times an x would give us an x squared, so this top length right here would be an x. So we'll represent that with an x piece. This length right here is the same length as this unit square. This side length right here would be an x, but this length right here is a 1. We'll represent that with a 1 block. And the same for the next 5 pieces. So we've got an x piece and then 5 1 pieces. Along the side, we've also got an x length, which we represent with an x piece. And then we've got 3 1 pieces that we're going to represent with these unit squares. If we take x times x, that gives us the x squared. The x piece times this 1 piece will give us an x, and so on and so forth. So you take the first piece and multiply it by every piece in the top column, and that'll give us our first row of blocks. Same thing for the second piece. So 1 times x gives us x, and repeat the process for every piece in that column. Same for all the other pieces, we end up with our area. Now for one of our factors, we have an x plus a 5. So in factored form, open your parentheses, put in one of your factors, close it out. X plus 5. For the other length, we have an x piece and then 3 unit pieces. So we have an x plus 3. And those are our two factors. If we were to take these two factors, x times x would give us x squared, x times 3 would give us the 3x, 5 times x would give us the 5x pieces, and 5 times 3 would give us the 15 pieces. This would give us our product. For number 2, in this case we're no longer working with algebra tiles, we're just working with our box. Now, for this x squared term, it has a coefficient of 1. So, an x and an x will give me an x squared. So x times x gives me that x squared. Now, I need not only to find factors of 15 that will give me 5x and 3x, but that will also multiply up to 15. In this case, if I were to take x and multiply it by 5, that would give me the 5x. So x times 5, 5x. For this x, I need to multiply it by something that will give me 3x. So I need to multiply by positive 3. X times x, x squared. X times 5, 5x. X times 3, 3x. 3 times 5, 15. So it looks like we have our factors. If you notice, when we have a coefficient of 1, all we did was take this coefficient, move it up here, and this coefficient, and moved it to the side. So a coefficient of 3 is represented with a positive 3, coefficient of 5, positive 5. And that works anytime you have an x squared with a coefficient of 1, and you have your other terms filled in. So in this case, our product, we need to take all of our like terms and combine them. We have an x squared. A 3x and a 5x will give us an 8x. We keep our base and exponent. If you don't see an exponent, it's a 1. And then add or subtract the coefficients as necessary. It's a positive 3 and a positive 5, so we get an 8x. And then a 15. For our factors, they're along our top and side. We've got a factor of x plus 5 along the top, and a factor of x plus 3 along the side. Our product is x squared plus 8x plus 15. Our factors are x plus 5 and x plus 3. Looking at number 3, you'll notice that there is a 2 as a coefficient on the x squared term. So our process of taking the coefficients in front of our other terms and moving them up isn't going to work for this. For these kind of problems, you're going to want to attack them with greatest common factoring. So I'm going to factor along this side first. So I need to think of the greatest common factor of 2x squared and 8x. 2 will go into 2 and into 8. So I have a 2 so far. And x squared and x both have one x in common, so I can factor out an x out of both of them. So the greatest common factor for 2x squared and 8x is 2x. 2 goes into 2 and 8. X goes into x and x squared. That's this factor. Along this factor, for this side, x and 4 have no common factor other than a positive 1. The 4 does not have an x, so there is no x I can factor out. And there is no coefficient that I can factor out besides 1. From 2x squared and x, the only coefficient that I can factor out would be a 1. But these two terms both have an x that I could factor out. This term has 1x, this term has 2x's. Remember, x squared can be represented as x times x. So there is 1x here, 2x is here, so there is a common x I can factor out. And finally, if I'm going to factor out here, out of 8x and 4x, the 4 does not have an x, so there's no x I can factor out. But 4 goes into itself and into 8. The greatest common factor of 8x and 4 is 4, positive 4. Now let's check if this works. If we've got 2x times x, that gives us 2x squared. 2x times positive 4 gives us 8x. X times 1 gives us x. And positive 4 times positive 1 gives us 4. It looks like we have our factors. So along the side, we have the 2x plus 1. And we also have along the top an x plus 4. For our product, we take all of our like terms, in this case our 8x and our 1x, and combine them. We've got only one 2x squared. 8x plus 1x would give us 9x. We kept our base and exponent, and then added the coefficients, 1 and 8 and 1 gives us 9, and then the 4. For number 4, we can use our greatest common factoring method again. So let's factor out along the side. The greatest common factor of 4x squared and 10x would be 2x. A 2 can go into 4, and a 2 can also go into 10. They also have one x in common, so a 2x. For 2x and 5, the greatest common factor, again, in this case, would be a positive 1. The 5 does not have an x to factor out, and 2 cannot go into 5. So 1 is the common factor for these two. Working across the top, 4x squared and 2x have the greatest common factor of 2x. 2 can go into 2, and 2 can also go into 4. And 4x squared and 2x have one x in common, so I factored out that x. For 5 and 10x, their greatest common factor is 5. 5 can go into itself, 10 can and 5 can also go into 10. The 5 does not have an x, so there's no x to factor out here. And I'll put my positive 5. Now we can verify 2x times 2x gives us 4x squared. 2x times 5 gives us 10x. 2x times 1, 2x, and 5 times 1 is 5. So for our factors, we can write 2x plus 1, and we can also write 2x plus 5. Our product, we only have a 4x squared, and that has no other like terms. 10x and 2x are our like terms, which makes 12x. And then we have a 5, a positive 5, so plus 5. For the next set, now we're working with number 5. Again, notice that this has a coefficient of 1. So what we can do is write an x and an x. That gives us our x squared. We can take this coefficient and move it up here. Now don't forget, there's a negative 6x. So the coefficient is negative 6. Moving on up. We have a coefficient of negative 9, so I can write out x minus 9 as one of my factors. And we can verify. X times x gives us x squared. X times negative 6 gives us negative 6x. X times negative 9, negative 9x. And a negative 9 times a negative 6 will give us a positive 54. A negative times a negative is a positive. And then 6 times 9 is 54. So for our factors, we can write x minus 9 and x minus 6. Our product can be obtained by combining any like terms. X squared has no other like terms. Negative 6x and negative 9x. In this case, we have the same signs, so we add the two numbers. 9 plus 6 is 15, and keep the sign. Our sign is negative, so it would be negative 15x, and then a positive 54. For number 6, we're back to not having a coefficient of 1 on our x squared term, so we'll have to work with our greatest common factoring method. For 2x squared and 10x, they both have 1x that I can factor out, and 2 goes into 2 and into 10. So there is a 2x I can factor out here. Now you'll notice that there are negative signs, so we'll not worry about the signs for now. We'll factor out what we need to factor out, and then we'll put the signs as necessary. For negative 7x and 35, negative 35, I can factor out a 7. 7 goes into itself, and it also goes into 35. We'll worry about what sign it's going to be once we get all of the numbers across the top and the side. For 2x squared and negative 7x, they both have an x that I can factor out. 2 cannot go into 7, so there is no 2 to factor out. We could factor out a 1, but we don't need to write the 1. And then for 10 and 35, 5 can go into 10, and 5 can also go into 35. So I will put a 5 here. Now if you notice, this is a positive 10x. So a positive 2x times a positive 5 will give me a positive 10x. But this is a negative 7x. I have an x and a 7 that would give me positive 7, so I could factor out a negative 7. Now if I multiply x times negative 7, I will get my negative 7x. And then the negative 7 times the positive 5 will give me my negative 35. So for our factors, we can write 2x minus 7 and x plus 5. Our product is obtained by combining any like terms. We have 2x squared, 10x minus 7x. Different signs, so I subtract 10 minus 7 is 3, and keep the sign of the larger number, which in this case is 10. So we'll keep a positive sign. 10 minus 7 is 3, x, and then the negative 35. Finally, we have the steps in the factoring process. Step number 1 is to put the numbers in the correct position in each box. Step number 2, write the product. Step number 3, write the factors. Now we've been kind of mixing up step 2 and 3, but it's okay. We can work with what we've got. So we'll work the 3-step process in order this time. For number 7, remember our x squared term always goes in this top left box. We've accounted for the x squared term. Now our c value, our constant, goes in the bottom right box. And 8x and negative 6x, the other two, can be filled in wherever you need to fill them in. I'll fill them in here, but you could have put the negative 6x right here and the 8x here. We've accounted for those. Now we need to write the product. So we have an x squared. We have an 8x and a negative 6, different signs, so subtract 8 minus 6 is 2, and then keep the sign of the larger number, which in this case is 8. 8 is positive, so we'll be keeping a positive 2x. And then a negative 48. Now we have a coefficient of 1 in front of our x squared term, so an x and an x make the x squared. We have a positive 8 here, so we can move it up here. And then we have a negative 6 here. We can move it out to the left. X times x, x squared. X times positive 8, 8x. X times negative 6, negative 6x. And then negative 6 times positive 8 would make a negative 48. So our factors will give us x minus 6, and then x plus 8. Now, for number 8, let's work our first step, which is to write everything in the correct box. Our x squared term has to go here, which, notice, it does not have a coefficient of 1. Our c value, bottom right box, and then we'll fill in as we need. The negative 21x and the negative 10x. Notice we have positive and negative signs, so when we do our greatest common factoring, we'll worry about the factor and then fill in the signs as we need to. So, across here, we've got 3x squared and negative 21x. 3 can go into 3, and 3 can also go into 21. And they both have at least one x. Here's an x here, and there's two x's here, so I can factor out a 3 and an x. For 10x and 70, 10 can go into itself and can also go into 70. 70 does not have an x, so there's no x to factor out. So I can factor out a 10. For 10x squared, or 10x rather, and 3x squared, we can factor out an x. 3 cannot go into 10 evenly, so we're just left with factoring out our x. And notice, 3x times x will give us our 3x squared. And then for negative 21x and 70, 7 can go into 21, and 7 can also go into 70, so I can factor out a 7. Now notice, I have a negative 21x, and right now I have a positive 3x and a positive 7. I need to maintain my x squared term. I need to keep it positive. So I'm going to make the 7 negative. Now 3x times negative 7 will give us the negative 21x. And notice here we also have a negative 10x. We need to keep that x positive, so we'll change this 10 to a negative 10. And then we'll get x times negative 10 gives us negative 10x. Negative 10 times negative 7 will give us a positive 70. And my apologies, I forgot to do step 2 and write out the product. We've got 3x squared, negative 21x and negative 10x. Same sign, so keep the sign. Add the numbers. 21 and 10 makes 31. 31x. And then a plus 70. And we already did the factorization process, so now it's just a matter of writing it. We've got a 3x minus 10. And an x minus 7. Hopefully now you have a little bit better understanding of how to do factorization with the box method.